Okay, 5:15 and welcome officially. I think I was supposed to give this talk in English. So let's do that also for the sake of the people online. I see there's video. Hey. Yeah, welcome to the no restore solution, which is technical speak for quality assurance for contingency plans, which is like business speak for the same thing. I hope to tell you a story that is not only a little bit entertaining, but also will help you to put forth the whole idea of backup and disaster recovery preparation within your organization, gain support, convince bosses, get the love of your fellow engineers, and so on. What will we be looking at? Quick recap of the important things like what do we talk about, a little bit the challenge we're facing, and obviously the solution. And I hope that your disaster recovery plan looks better than this computer-generated illustration. But maybe this is actually a photo and I didn't tell you. So, quick recap. What is business continuity? And I personally am a really big fan of words. I actually love to write, and I don't know how to make drawings, pictures, whatever, because writing is such a precise art. So I tried actually to go and create a fairly precise definition of business continuity. And I believe this is somewhat okay-ish. And the way how to measure the quality is, can you turn that into an implementation? Can you like take every word and follow this as a plan taking you into a successful completion of this problem? And I believe you can. Yeah, comprehensive strategy, so all the organization needs to continue operating, check, 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 delivering critical functions during and after unexpected disruptions. The after part is really, really important. Minimizing downtime, maintaining essential business processes. It's about the business. So in other words, staying in business no matter what. And that's the important part here. And whatever people tell you about business continuity, it really boils down to that. We need to stay in business. And to be honest, as an employee, I have a really vested interest in that. I'd like to keep my job. So from a very, very selfish perspective, I have a little bit of a hobby talking about business continuity and helping people to find their way into this topic. Quick recap of the general timeline of what typically happens. So time starts on the left, goes to the right, and eventually you end up making a backup. We also in the beginning, you all do backups, right? Backup, 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 backup? Yes, yes, we all do backups. We're good people. Eventually, you do another backup, right? Eventually, you do yet another backup. But then, boom, something happens. Your entire environment blows up. And trust me, it will blow up in the middle of the backup. Murphy and all that. So then, headless chicken mode on. Then you somehow manage to facilitate a partial recovery. The emphasis being on partial. You will recover some of your systems somehow in some fashion with some functionality and crucial data missing. You keep working, less headless, more chicken, and then you will have a mostly recovered system. And then you say, well, we're done. You just accept the little gap here of, well, this was bad luck. Why? That's how technology works. Plus, maybe the cost of losing that is smaller than the cost of keeping it. Just for the terminology that you have seen it once, no talk about backup without RPO and RTO. Very easy to remember because I had a hard time remembering it. RPO is how old is the recovery data, meaning how far do we travel back into the past to find a working backup. And the RTO is how long does it take to recover. So how much time passes before we actually start to make use of the old data that we collected. So RPO and RTO together is essentially your outage, right? That's how you can maybe remember it, or even easier to remember, RPO is the stuff we have in our pockets, and RTO is the stuff we will do with it. So have and do is RPO and RTO. What is the problem? I believe the problem that we face in this day and age is too much data. Too much data, literally too much data. How do I know that? Not only from all of my customers, but actually there is a survey or like a research by somebody that we have a lot of data, and this lot of data is so long that I needed to actually find out how to write it. And if I look at my customers or any other environment, we see this exponential growth of data for whatever system you happen to be looking at. I mean, you know, who deletes email anyway? Right? Who's in the cloud and deletes email?
Only the alerts.
Yeah, good. So data keeps growing, and there's nothing we can do against it because the business wants to have the data. Users maybe don't want to delete data, don't know how to delete data. Maybe we don't want to stop the company because the Outlook PST file has a limit of 1 gigabyte, whatever. So the other problem is, of course, time, right? Time is a finite resource, so I believe there's not enough time to restore all the data. There's a huge kind of conflict between amount of data and the time available to restore. So looking at the evolution of disaster recovery, going back to the Stone Age, prehistoric times, computers are not born yesterday, I personally observe a kind of gradual reduction of RPO and RTO. And I call it the big squeeze. We're here, right? If you come to your upper management and you tell them, well, we'll be out of business for a week, and that's kind of great that we managed it so fast to come back into business, they will look at you like you're crazy. Because Google is never gone for a week. So why can't you be the same like Google? I mean, you're the admins we're paying, right? Obviously, you have to be at least as good as Google. Fact is, we actually need to do all the stuff ourselves. We can't rely on a large team of people at Google to do it for us. So how did your storage size increase? How did your recovery times decrease? Anybody wants to share an actual story from your environment? Come on, I'm sure you have some.
Did not yet have a successful recovery.
Okay, so this is like infinity. Good. Any other examples? Anybody had an explosion of data over the last 10 years? Please.
Sure, but mostly it's logs in graveyard stashes or something which you actually don't need in the case of disaster.
What happens if the disaster happens before the ransomware attack and then you need them? I don't know, but yeah, okay, logs, let's get rid of them. But what, you don't have ERP systems that suddenly have a tenfold increase, mail stores. I mean, I don't know people who really sit and delete mails. And mails keep growing, my file archive keeps growing, my photo archive keeps growing. I mean, I'm happy I'm on Google Workspace and there's so much storage, it's hopefully gonna last till beyond my pension age. But I know that this is a problem, and everybody who has a phone keeps generating data every day. What do we do with all that data? What would you do if it's gone? So let's look at a real example from a real environment. And this is like a little bit the kind of typical worst case scenario that you can use as an example to talk about stuff. SAN failure. Who here has a central storage area network somewhere? Come on, everybody has that in the basement, right? So very typical, not large environment, 140 gigabyte SAN storage. We use LTO9 tapes, which is almost state of the art. And just for reference, that's about 1.4 terabyte transfer speed. So if that all blows up, how do you do full restore? I would estimate it will take you a day to fix the storage. You know, you call the vendor, they come at night, you call them in the evening at 6, then in the morning at 6 they actually come. Then they do something and then it magically comes back, but oops, it's empty. So then you start restoring data from tape. It happens to take 4 days because of the amount. And you know, the tape library doesn't have a hiccup. The tapes are all readable, like all happy path. Plus 1 day overhead, getting organized, you know, starting systems, whatever. So bottom line, 5 days is your minimum recovery time for that scenario. Happy path, nothing going bad. Now the question is that actually okay? Would your business survive 1 week without its core systems? I don't know. By the way, not only you are not working internally, you're also not reachable from the outside. Because we all live in an interconnected world. So us not working is a problem, but us not being reachable from the outside, responding to emails, taking orders, writing people, hey, sorry, we have a slight hiccup, will be slightly delayed. No, Verzögerung im Betriebsablauf. All that is actually super, super, super problematic. And your internal disaster recovery plan doesn't cover it, most likely. And imagine, not just your central storage was busted, but let's say a ransomware attack actually wiped, encrypted, or whatever, all other hard disks in your environment as well. Well, going home and looking for a new job is one strategy. I personally actually prefer to work on the preparation side. And that's why I invented the no restore solution as an approach. And most important, how do we test this? How do we validate that whatever procedure we invented actually works? And you know, I'm not a developer by my training. I'm more like an ops do-it-yourself person. And I had to learn the hard way that test-driven development is really, really valuable. And then I had to learn the even harder way that test-driven development can be applied to stuff outside of core software engineering. And that's what we talk about. How can we use test-driven development as an idea for something like disaster recovery? How often can you actually exercise your disaster recovery plan? Like, you know, every Monday, and every Tuesday, and every Wednesday. Wouldn't that be nice? Wouldn't it be cool if you could, you know, just keep it running, you know it works. If it blows up, you just know what will happen because it ran every day in the last 2 years. Imagine how much peace of mind and good sleep you will gain from that. So, obviously, the SLA is the RPO and the RTO and a lot of hope and prayer, right? That's the kind of precise scientific definition of SLA. And I had the idea, how can we kind of optimize that? And the idea was really, okay, RTO and the unknown is like the biggest problem. How do we attack this biggest problem? Let's simply go and get rid of the restore time. Because that's the biggest problem, like the restore time and the uncertainty that it brings with it. So the other idea was, you know, test-driven development. Let's keep exercising the restore process all the time. So I want to get rid of it, but I want to try it all the time. Obviously, compatible objectives. And the solution is you need to restore every backup immediately. The job isn't done after taking a backup. The job is done after the backup was proven worthy. And that's the big mindset shift that I'm trying to sell you on here. So if you do that, you will get a replacement system that is ready for usage because you just recovered a backup on it. So essentially, instead of trying to restore something when we need it, we go and switch to a working system in case we need it. And that is a fixed RTO because, you know, it's already there. And yes, of course, that doesn't come for free. But you know, business outages also don't come for free. So maybe there's a good trade-off here. Let's look at this whole story again on our timeline. So backup, check, and then we restore it automatically. So you take a backup, have an automated restore, an automated check that makes sure the restore actually worked, that you have a recovery system that actually works and can do its job and has the data and so on. And you see, the bubble is much more filled than previously. There's maybe a little gap, but okay. Then we again have the backup, it blows up, and oops, we switch over, and we're done. So easy. The fact that we automated the restore and automated the check and have a ready recovery system allows us to switch over, in case of a disaster, to a working alternative. And I can promise you, this is cheaper than the long outage with a high uncertainty. So the recovery time is just the time it takes to start the recovery system. That's the no restore solution in the nutshell.
How is that different from having a hot standby?
Good question. Typically, you don't use, so the question was, what's the difference between the no restore solution and a hot standby or a, cluster, replicate, whatever. So the crucial difference is that you use your backup and restore system to facilitate the process. Your cluster, replication, hot standby synchronization actually is a different mechanism. It's not backup and restore. It's online replication, meaning all the problems will be within seconds in your hot standby and will actually render it unusable. The crucial part is this check, that you take a backup, you restore it, you check it, it's a validation, and this is the proof of we can recover. This check is important. Your replication cluster, whatever, doesn't have checks going on the standby node. It just assumes that the standby node will be able to function when you need it.
What kind of checks would there be? Is that something you cover later?
Whatever you fancy. Think system test, integration test, whatever you need to do in order to make sure that this recovery system is usable for business purposes.
It's really meant to be a kind of a system check.
Yeah.
Full system.
As much confidence as you want to have in this process, that's how much checks you need to build up here. Because the whole point is we shift trust from people into automation, one of my DevOps principles. So instead of trusting people to know what to do when, shit hits the fan, we build automation that we can actually develop TDD, test all the time, validate, and so on, and make sure that the automation works well. And then if the admin is on holiday and this happens, it will still work very well. So we actually, as a mindset shift, we shift trust from individual people and their special magic foo skill into automation that everybody can understand and employ. And that's the magic here. Good so far? Interrupt me with questions, no problem. So, remember, please remember, if that's the only thing you take away today, please remember, RAID is not a backup. That's the answer to your question, actually. So any sort of cluster, replication, SAN mirror, whatever you name it, is RAID in more expensive. It's not a backup. It will replicate all the problems to the other node and faithfully keep them there as well. Whereas backup is really exporting everything into a typically other format that you can transport somewhere else, recover, validate, and actually rely on. So the quality of assurance happens in the backup and restore, not in the replication. Please, RAID is not a backup, okay? So, backup 1, 2, 3, you probably know that. You have a primary data store. So the important thing is to remember, if you want to reduce RPO, you need three things: snapshots, replication, and offsite backup. That's the traditional backup 1, 2, 3. So in the example, we have a primary, you create snapshots. That's your backup level 1 if you want. But remember, this is more like, almost like RAID. It's RAID with a disconnect. So if the primary dies, and you realize it 5 minutes later and activate the snapshot, there's a high probability the snapshot will die 5 minutes after you activate it. That's why this is kind of too much coupled for you to really rely on it for hardcore recovery scenarios. Then you, of course, copy the snapshot somewhere else. That's replication. And by the way, all the replication systems kind of do that internally. So they take a snapshot, replicate it, take another snapshot, replicate it. And then you talk about offsite backup, like disks, tapes, whatever, doesn't matter. Somewhere else, disconnect it, unplug the cable if it's not used, switch off the server, all good stuff, but that's step 3. So please, backup 1, 2, 3, still valid today, even though it's really ancient as an idea, it's still important. What else? The myth of only business critical systems. Who here has done a business impact analysis? Come on, some of you are ISO. No? Everybody who's ISO certified needs to have that. It's part of the compliance. Okay, you want to stay anonymous, I understand. So, what's the problem? The problem is, I believe it's an illusion of clarity that we know what our business critical systems are. In fact, people work on their own, create solutions outside of official processes and outside of official systems. So taking only care of so-called officially labeled business critical systems has a high likelihood that in the end, you will actually miss something, which is why I personally recommend recover everything. We have the technical means to just recover everything, let the users work how they want, and give them this safety net of we can recover everything. And if I can't recover it, I'd rather switch it off immediately than run the risk that I won't be able to recover it. Please also think about software as a service. And in my talk tomorrow, I have a bit more depth on that. The general problem is software as a service doesn't have backup. This is your production, this is your backup after restoring it, in a nutshell. I ran a study on Google Workspace, but every other SaaS out there behaves exactly the same. Same problem, same challenge. The core question is, do you have possession of your own data? And the answer is no. The whole point of SaaS is you don't possess your own data. They possess it for you. Means you have ownership, you have an entitlement, you don't have possession. Plus, there is no backup. There is maybe an export. And the export cannot be imported. Again, nice example, Google Takeout. Ever looked at Google Takeout data? It's a bunch of JSON and HTML and a bunch of Office files. And there's no way how to put all that back into your Google account. Literally, no way. It's not meant to be. So you have your data, but you can't use it. So my lesson learned, my takeaway is SaaS means we accept that after a major outage, we start again on a lower level of functionality, a lower level of data, a lower level of everything. Backup and restore is a destructive process. And by the way, ever think about RPO and RTO and contingency plans for SaaS solutions? Please go home from this talk and know that Google and Microsoft and others, they don't take backups for you. They assume that nothing will ever happen. Sensible, right? Because it makes their job so much easier. But the problem with SaaS is the SaaS provider doesn't care if you delete your data or if an attacker deletes your data for you as a service. They just don't care. It's like, yeah, it works as designed. Somebody came with your login and deleted all the data. What are you complaining about? Oh, we don't have two-factor. Well, you knew that, didn't you? So yeah, your data, your responsibility. If you want to own it, possess it, you have to do something. More on my homepage. You can click on that when you look at these slides, which are already online. So what's the return of invest on disaster recovery automation? And the goal is that you don't feel like that. You can choose if you're the carrot or the donkey. This is real problem. We are all the people who need to recover things, who need to explain the big boss why we can't recover things. So for me, this is a big pitch for automation. And the main argument is automation is the only way to get guaranteed and provable quality for contingency plans with a proven time frame for recovery. Proven in the sense of it's here, I can show you. The test ran. It ran 2 days, and that's how fast we are. You want to spend another 2 million? Then it will be 1 day. No problem. At the moment, you have maybe a bunch of paper, a tabletop exercise. You don't even know if it will work. You don't know what goes wrong in reality when you actually need to do it. So for me, this is all about quality insurance and about provable quality and about making sure that, we don't have guesses. We know what we do. Obviously, yeah? Automate everything. If you're not automating it, it's probably going to fail. Like, think untested means broken. So test-driven development for infrastructure means automating the hard parts. Interesting thing, there are disaster recovery as a service providers and solutions. And I thought I'll show you some as an example of what can be done. Maybe the most well-known is VMware. So if you have a VMware-based virtualization infrastructure, you can literally go and buy a product that you can install, and then you can get vendors who actually provide you storage as a service and compute on demand as a service. So you literally replicate everything to the disaster recovery provider, and whenever you have an outage, you just activate it because the data is there, virtual machines are there in a way that can be started instantly. So it's ready to start, and that actually implements the no restore solution. It's exactly the idea that I showed you originally as a product that you can buy. Who here is using something like that? Anybody? Actually, I can tell you how you activate it in your environment, like with a click.
Oh.
Sorry. Veeam does the same, kind of same story, same principle, different product names. Hyper-V Azure, same story, same different product names, same idea again. Replicate everything, running virtual machines into the cloud as startable virtual machines, and when you need them, you can turn them on. Why do I show you that? Because that's the easiest way to solve a big chunk of the problem with money, which sometimes is actually a good deal. So as an example, I'm currently working with a client of ours, and I'm building a disaster recovery data center for them with the help of such vendors. And I can tell you that the pricing is actually okay in terms of insurance cost. So we have like 20 terabyte storage, and we end up with like about 60K per year, end-to-end full coverage, including yearly tests and everything. And I think as an insurance, this is okay. Because the effort to do other things, to use other means to create that level of instant recovery would be much more expensive. That's why I believe from a business perspective, it's money well spent. Especially if you have like, 1/2 admins who have lots of other things to do and don't really have time to build half a year an amazing disaster recovery automation. that nobody else would be able to handle. So here we go again. Standard solution, click, 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 done. That's the world we live in. If you want to look for more products, forgot about it, there's even like Certo, which does the same thing again in yet a different version for yet a different amount of money and promising yet another bunch of things that I haven't tested myself, just to give you a quick market overview. And there's probably more than them, just, do your own research. We're coming to the end, so allow me to share some personal materials. For and foremost, of course, Relax and Recover, my automated Linux bare metal restore open source solution. Started building that more than almost 20 years ago, still working on it. If you don't know it, and run Linux servers, please do take a look. It's the one and only standard open source product, part of all Linux distributions, works really well to facilitate fully automated bare metal restore. Then actually first touch that I had with the whole no restore solution was a customer project a long time ago. They needed a file server with a 2+ digit amount of terabytes attached to that. And they asked me, hey Schlomo, what can we do so that whatever fails in this file server, we can recover in like an hour? 2+ digit terabyte, SAN storage, big shit. And we thought about it a little bit, and we came up with a solution which I call the simple high available Linux file server, like virtual cold standby server. The idea was I have a hardware server that uses a SAN LUN or multiple SAN LUNs as data and runs a file service software like Samba NFS. So far, so easy, right? What do we do if the hardware fails? Well, we start the same thing as a virtual machine from the same LUNs. So if the hardware fails, we start it as a virtual machine. Runs a bit slower, but it actually works. People can keep working. What do we do if the SAN storage fails? No problem. We just add 5 shelves of disks to that hardware server, local disk, and set up rsync as a mirror. So if the SAN fails, I reboot the server from the local disk and keep working. So for that scenario, when the SAN comes back, I of course need to reverse the rsync. So if I ever mounted the local storage for production, then it's kind of tainted, and I make sure not to automatically start the rsync again. Bit of Linux scripting, no problem. So in the end, we had a double redundancy without double the cost. That was the whole point. And no restore solution. Actually ended up writing an open source project for VMware's backup solution when they brought it out. Who remembers VCB? The first backup tool from VMware running on a Windows server that could actually pull virtual machines live from ESX and put them on the Windows box in a format that you couldn't do anything with. So I wrote a tool called EasyVCB that would actually facilitate this process and convert the virtual machines into a startable format, and ideally put them on a NAS box so that another ESX server could then start them again. There you go, no restore solution. And I did a deep dive of why SaaS sucks from a backup and disaster recovery perspective. And in general, test-driven infrastructure is my approach for DevOps risk mitigation, for handling all kind of dangers around automating things. If you automate more, then you need to also test more. So, quality assurance for contingency plans. How does it work? 3 things you need to keep in mind. Please automate the disaster recovery to eliminate risk and uncertainty. Automate. Idea, switch to a recovery system to quickly recover from outages. And obviously the recovery system works already. You know it, you prove it, so it's reliable. And finally, test-driven development as the general approach to doing business continuity. If you do all 3, you'll be fine. So, we have a few minutes for questions. Obviously, I work as a consultant, so here's the pitch. come and take a look at my homepage. There's links to the slides, to the other talks, to videos, to my homepage, blog, and so on. And I'll be happy to come and support you in any fashion that we can help. Please do send me an email. I'll be happy to respond with the link to my slides and whatever material you request. And yeah, if I can help you to take good decisions around your IT topics, then this is something that I like to do. Thank you very much. So, questions, please. And if there are any people online, please write your questions in the chat. Please.
Do you plan the recovery system the same size as the original system, or do you plan them smaller?
So the question is, can you get away with a smaller recovery system? I would say that's a business question. In the age of virtualization, typically you have like a larger primary platform and then a smaller emergency platform where you maybe start the really, really important systems to get the company back into a working state, like, communication, collaboration. And then you tell the people, hey, people, we have an outage, please be patient. And then you start more things, maybe buy another server, plug it in, recover the other ones. It's always about having the means to do something and not, stand with empty pockets. So exactly how big your recovery system needs to be, I don't know. That example that we mentioned, 20 terabytes, 60K per year. So they have about 20K per month running costs if they use the recovery system in full on the disaster recovery data center. And we actually calculated for 3 months we might need it. So this would be kind of 90 to 100K, which is, hey, cheaper than buying and maintaining spare hardware. Plus, it's another site. So if our primary site blows up, we still have another site with all the data. It's not just enough to have spare hardware in the same server room. You also need this geo redundancy. Plus, we also said, let's use terminal servers or VDI to actually give desktops to users in case the outage also encompasses their desktops. So let's say we have a ransomware attack, all their laptops are, bust. Then we can start our disaster recovery environment. Everybody goes remote and keeps working. So there are things you can do with these architectures to scale out of all kinds of outages. Please.
If you have a system that you're running which is being already rolled out via infrastructure as code, so that you have, for example, a vagrant machine that gives you a basic Linux machine with all packages you need, and then you have like Ansible or something that runs on the actual software, would that still make it feasible to say, I make the disaster recovery by replicating the entire VM that is running, or would it also be a feasible approach then to just say I'm backupping the data and I'm always running a hot spare where I just roll out my infrastructure as code, playbook or whatever, to have a hot spare basically standing by on a snapshot of the backup data?
If you trust your automation, you don't need to keep it active. You can just trust it to work also when you need it. In general, automating code and config is easy, and automating data is really hard. So if you have that level of automation, I would actually suggest for you to think about how you can automate the data, backup and restore as needed. Meaning, imagine the server comes up and says, ooh, I don't have data, let's get it from the backup. So you actually automate the restore in a way that the whole system comes back with the latest version of the data if the data isn't there. But like I said, automating data is hard, and if you make a mistake in the data automation, maybe the data is gone. Whereas if you make a mistake in your code and config automation, you just delete it and try again.
Yeah, but that is obviously have to work. I mean, in order to successfully back up the data, you have to successfully back up the data. That's kind of obvious.
But I wouldn't keep systems running. I would keep automation that is proven and has a high quality and rely on it doing its job when I need it. So
run the backup and then just shut it down again?
Yeah. No, run the backup, restore it, have a system you can just switch on, and it will switch on when you need it.
But not have it switched on all the time.
No. Exactly. That's also the principle behind the disaster recovery as a service. You replicate the data, so you pay for the data, but you don't pay for the compute and network and whatnot. And then you pay for the compute when you need it, but not when you don't need it. Because most likely your disaster doesn't coincide with the disaster of the other customers of your vendor. Yeah, hopefully. Yeah, it's a trade-off. Yeah, it's a trade-off. But no, if you don't do this trade-off, you can just build a backup data center and just have the full capacity there for yourself. So the question is, what is the cheaper, more affordable, more reliable way? Maybe you don't have a second data center at another location with redundant everything. Please, more questions? Who goes home and starts working on their no restore solution architecture? You? Thank you. Okay, thanks a lot. I'll be here also tomorrow. Tomorrow at 11 something, there is another talk about a similar but not identical topic. Tomorrow's talk is about backup and restore, everything business as usual or what needs to change. In that talk, I'll give you much more details about what is actually changing for backup and disaster recovery as we go into cloud, into SaaS, into kind of more distributed systems, and what kind of challenges do we need to solve today. So this was a bit more technical deep dive. Tomorrow it's more like business, IT strategy, and so on. Stuff you can use to convince your management in the elevator to do the right things. So thank you very much. Send me an email and let's stay in touch. All the best.